Okay, let's unpack this. Today, we are doing a deep dive into what is really a blueprint for the future of supply chains in this country. We're talking about Australia's National Framework for Recycled Content Traceability.
Mm,
And if your mind immediately jumps to, compliance officers and stacks of paperwork, I want you to stop. This is a fundamental shift in business strategy. This isn't just bureaucracy. It's about competitive advantage. And frankly, it's a requirement for future market access.
that urgency is it's palpable. I mean, the consumer has really driven this change, and they are putting their money where their values are. The data we looked at is just staggering. A massive 73% of international consumers demand product traceability. They really want to know the story of what they're buying.
And here's the bottom line. For every CEO, every procurement manager listening, it's the other stat, 71%. 71% of those consumers are prepared to pay a premium for that transparency.
Exactly.
So if you can't provide verified proof of recycled content, you are literally leaving margin on the table. The market has spoken.
Precisely. And that's why the framework has this critical dual mission. First, it's about rebuilding trust, internally. It's the essential tool to minimize the risk of fraud and definitively stamp out greenwashing in the Australian market. It protects legitimate businesses.
Right. So it makes sure that the claims people are making are actually backed up by verifiable data.
Yes. And second, it's about global connectivity. This national standard is proactively aligning Australian industry with these rapidly intensifying traceability mandates. We're seeing them from major trading blocs.
The big ones, the EU, the USA.
Exactly. The European Union, the USA, Canada. If you want to keep selling into those markets, this alignment it's mandatory for survival. It's not just optional for goodwill anymore.
So without this kind of standardization, market access just becomes really precarious.
It does. And maybe before we get into the mechanisms, we should quickly confirm the scope for you.
Good idea.
The framework is sweeping. I mean, we're talking about all recovered materials, recycled materials, and the resulting products. So that could be consumer goods, heavy industrial components, or even construction aggregates. It covers materials produced or imported, both pre-consumer and post-consumer waste.
And importantly, it also includes all recycling processes. Even those really complex chemical transformations, the advanced or feedstock recycling.
Yes, the ones that change the material structure entirely. The whole life cycle is in scope from the moment of material recovery right through to the final sale.
Okay, so every single entity in that supply chain that handles these materials is covered.
That's right.
So we've established the why and the what. Let's dig into the how. I mean, how does this actually work? Let's start with the rules of the game. A traceability system is only useful if it can talk to other systems, right? So interoperability has to be the bedrock of the framework.
Absolutely. Interoperability just means different IT systems can connect and share data seamlessly. Doesn't matter what proprietary software you're using. And to stop this from becoming a patchwork of, isolated databases, the framework explicitly ties its guidance to the GS1 Global Traceability Standard.
Ah, okay. So that provides a kind of universal language.
It does. Common data formats, common unique identifiers. It allows materials to travel across company boundaries without losing their sort of identity documentation.
It's like giving every batch of material a standardized, readable passport that works in every country.
That's a great analogy. And the entry point to this whole system is elegantly simple. Maybe deceptively simple. It's called one step forward, one step back, traceability.
Or one up, one down.
Exactly. It's the minimum standard. And it's designed to get everyone participating immediately without demanding, perfect global coverage from day one.
So what does that actually mean for a business?
It means you must be able to document the movement of a material batch one step forward to your direct customer. And you have to be able to trace it back one step to your direct supplier. That's it.
Okay, so if I'm a manufacturer, I don't need to know the absolute initial source of the plastic or who the final end user of my product is?
Not initially, no.
Yeah.
You just need that ironclad data connection to the company immediately before and immediately after you in the chain.
And there are clear boundary lines, right, at the beginning and the end of the cycle.
Yes. Material recovery operators, so at the very entry point, they are not required to trace feedstock back beyond their sorting or aggregation point.
Okay.
And likewise, the final sellers, retailers, they don't need to trace forward to the consumer. They just trace back to their direct supplier. It distributes the burden fairly.
Okay, but here's where it gets really interesting, though, because one up, one down is just the starting line. It is definitely not the finish line.
No, not at all.
The framework sets a pretty demanding goal for full systemic capability.
And that deadline is critical. While you start with one up, one down, All participants are tasked with working towards tracing recycled content across the full supply chain. That's between the entry and exit points. And the deadline is the end of 2027.
4 years. That goes by very, very fast in business,
It does.
especially when you're coordinating across multiple independent companies. For anyone listening, that 2027 deadline means the clock is already running. You've got ERP integrations, staff training, onboarding reluctant supply partners.
It's the hidden cost of coordination that's the real killer. If you wait, you risk losing your trading partnerships because your upstream suppliers just haven't bothered, or your downstream customers demand a level of data that you can't provide.
So the key action now isn't really selecting a system, is it? It's mapping your supply chain.
It's mapping, identifying those friction points, and having those challenging conversations today. Because trying to do that in 2027 under market pressure, the cost will be exponentially higher.
Right. So moving on from movement to measurement, let's talk about composition. Figuring out the guaranteed percentage of recycled content seems like the trickiest part, because once materials are all mixed together, you can't really test the final product to verify a claim, can you?
You can't. You can test for chemical purity, but you can't look at a piece of polymer and say, ah, yes, this specific molecule came from a post-consumer waste stream.
Right.
And this is why the framework accepts 4 distinct chain of custody or COC approaches. They establish the claim through systemic accounting, not just physical testing.
Okay, so what are they?
Well, 3 of them are based on physical segregation. You have 100% known content. We start with identity preservation. This is the absolute gold standard. Materials from different sources are meticulously kept separate. They never mix. Think dedicated sterilized production lines, separate silos.
Which I have to imagine is commercially non-viable for almost any high-volume manufacturer. The cost of duplicating all that infrastructure would be astronomical.
That's exactly right. It's usually only for extremely high value or highly regulated materials. So slightly less stringent is segregation. Here, recycled materials with identical characteristics can be mixed together, but they are never blended with non-recycled or virgin materials.
So it's still 100% recycled content, but the specific source is a bit more generalized.
Correct. And the third physical model is controlled blending. That's where you set a known recipe from the start. Recycled and non-recycled materials are mixed, but only in specific verified ratios. So you get a perfectly known pre-calculated percentage in the final batch.
But all 3 of those methods, identity preservation, segregation, and controlled blending, they all require pretty intense physical segregation systems.
They do. Which brings us to the most flexible model, mass balance. This is likely going to be the accessible entry point for most participants
Why is that?
because it relies on meticulous record keeping rather than expensive physical separation. It's an accounting solution.
Okay, so how does it work?
The rule is pretty simple. Recycled materials and virgin materials can be combined at any point over a defined balancing period. The framework recommends 3 months with a maximum of 12.
And what's the crucial accounting rule?
The total volume of your claimed recycled output over that period must not exceed the total volume of verified recycled input you put in, adjusted for processing losses.
You have to prove you put it in before you can claim it came out.
That's the principle. It relies entirely on verified inputs driving verifiable outputs.
Okay, let's use the mandatory analogy here, the biscuit bakery. Walk us through how mass balance works with something tangible like flour.
Okay, so we have a biscuit manufacturer. They purchase standard flour, and they purchase certified organic flour. For our purposes, the organic flour is the verified recycled content.
Got it.
They store both types of flour in one giant silo because, maintaining 2 separate sets of storage and piping is just prohibitively expensive.
Yeah. Okay, so the second those flours are in that silo and mixed, physical segregation is completely lost. You can't test a biscuit and tell which flour went into it.
Correct. But the mass balance accounting tracks the input volume over, say, the quarter. Let's say 30% of the total input flour was organic.
Right.
So across all the biscuits produced during that quarter, the manufacturer can legitimately claim up to 30% organic content across their total output volume.
So even though some individual biscuits might physically be 100% standard flour, and others might be 100% organic, the system balances out on paper over that accounting period.
Exactly. It transfers the claim based on the flow of the input volume. This is essential for fields like chemical recycling. There, the recycled plastic is broken down into a base oil, a feedstock, which then mixes perfectly with virgin oil in a refinery. The system tracks the flow of the attributed claim, not the physical molecules.
That makes technical sense, but the system relies entirely on the integrity of the accounting. I mean, what prevents internal fudging?
That's a great question. And it's why the framework demands intense scrutiny on the management side. The allocation has to be based on known quantities, supported by a formal material accounting system, and it has to be kept material-specific and site-specific. You can't share credits between different facilities or different material types, for example.
So you can't claim recycled plastic output based on paper input.
Absolutely not. And this is where external audits and mandatory data sharing become crucial to verify the integrity of the whole system.
And speaking of integrity, this brings up the critical constraint warning that every business must internalize. The framework explicitly does not support the book and claim model.
This is a clear line in the sand. Book and claim is purely a financial transaction. A company can buy a recycled credit from a recycling facility. They're effectively paying for the environmental benefit without ever receiving, handling, or incorporating any physical recycled material into their own product.
And the framework sees this as undermining the entire goal of physical traceability.
Yes, it actively enables greenwashing by allowing products with zero physical recycled content to carry a claim. It has to be physical material entering your process.
Okay, let's transition to the final layer here: quality, safety, and data. Because it's not enough to just know where the material came from, we have to know what it is and that it's safe.
And that's where we invoke the powerful guiding principle of the framework, the precautionary principle. This concept is laid out in Section 2.3, and it's non-negotiable. If there's a credible threat of serious or irreversible harm from using recycled content, a lack of full scientific certainty cannot excuse you from taking measures to avoid that harm.
So if you're unsure, the default button is unsafe. What does that practically mean for a business? What's the cost?
The cost is immediate expenditure on risk mitigation. If your feedstock origin is unknown, or if the material contains legacy waste, say old plastics that might have historically banned heavy metals, you can't just proceed. If your information is insufficient to complete a robust risk assessment, the framework mandates that you must assume the recycled content is not safe for its intended use until you can verify it with testing.
Wow, so that means spending significant resources on immediate third-party verification or halting production. It sounds like you almost need a corporate archaeologist to trace the history of every piece of plastic.
In high-risk scenarios, that level of due diligence is essential. And this is especially critical for things like children's toys, food contact packaging, or hospital equipment.
Okay, so to make all of this possible, the provenance, the mass balance, the risk assessment businesses need to collect and share a serious amount of standardized information. The key data elements.
Yes, the KDEs. They're essentially the universal passport and manifest for every single batch of recycled material. And the real challenge isn't the list itself, it's the integration. This information often lives in all these different systems, the ERP, the warehouse management system, maybe a binder in the manager's office. You have to automate the sharing of this data.
So what are the non-negotiables? What must be shared one step forward and one step back with every transaction?
You absolutely must share the unique item identifier, the precise quantity and unit of measure, the shipment, sender, and receiver identifiers, and the ship date and location. And crucially, for material recovery and reprocessors, the processing method must also be declared. This tells the next buyer exactly how the material was treated.
And if you're using mass balance, that adds another whole layer of transparency your partners need to see.
It does. To support a mass balance claim, you must also share the claimed recycled content percentage, the specific chain of custody approach you used, the start and end dates of the mass balance period, and the precise allocation method.
It's standardization leading to auditability.
Exactly. It tells your customer exactly how you arrived at that percentage figure.
And the beauty of this level of detail is that by standardizing these KDEs and aligning them with GS1, Australia is making it far easier for businesses to comply with things like the new digital product passports required for the EU market.
It's a strategic defensive move for the entire country's export market. So if we synthesize this whole deep dive, the framework is Australia's comprehensive answer to this global demand for verified, high-trust recycled content. It gives us a standardized, interoperable path forward, driven by GS1, moving from that basic one-up, one-down tracking towards full supply chain coverage by the end of 2027.
And it all hinges on adopting systemic transparency, which means integrating data systems now and committing to safety by rigidly applying that precautionary principle, assuming risk until proven safe.
Wow.
This is about building a circular economy that the world actually trusts and is willing to pay for.
A critical undertaking for the Australian economy and really for every business operating within it.
The framework is voluntary today, but with the 2027 deadline looming and global markets tightening, the question isn't can we afford to trace our materials? It is can we afford not to?
A provocative thought to end on. Thank you for joining us for this deep dive.
We'll get you on the next deep dive.